Alright, so for our particles, this is our source, and we can call all of these black points, which basically have an age of 0, if we drop this into a pop replicate, or rather point replicate. And let's set the points per point to 1. And I want to check this generate from attribute option over here, and the attribute will be density. So now only the particles that have a density above 0 will exist, basically. And we can go to the shape and let's set the uniform scale to 0. So we will be emitting particles from all of these points. And let's maybe make our source last even less and adjust the ramp for our density. Alright, so from here I will drop this into a popnet. And let's go to the first frame and let's step inside our popnet. And we want for the source, let's turn off guides and use all points. And all of these settings should be fine, so we will leave all of these as they are. And let's press play and see what we get. Alright, so we start to emit points, and let's also give this a gravity as well. And we can see that in our source we are inheriting the velocity from the original debris source. And let's maybe just scale this down a bit to maybe 0.7. And also I want to randomize this velocity a bit, so let's go up and let's do the same thing that we did for the velocity source for our smoke. And I will just grab this attribute noise and I will just place this here after our popnet. And also inside this pop replicate over here, we have to make sure that for attributes we copy all of the attributes, and this is mainly to preserve the velocity of the points. So we can see that without this option now our points don't have velocity. So let's turn this on, and if I go to my attribute randomize, or attribute noise rather, we also add a little bit of noise to our points, and maybe we can readjust some of the settings. Alright, and because we copy all of the attributes, we are also copying an age attribute and a life attribute as well, so this will mess up our particle simulation. Let's drop down an attribute rename after the attribute noise, and we only want to keep the v, so the velocity, and delete the rest of the attributes. Let's go back and let's also set this to start at frame 20, so like our smoke simulation. Let's go ahead and preview this. So they are inheriting the velocity and then they are being affected by the gravity. So this is perfect so far. Let's go ahead and we can now take care of the collisions. Let's first go to the VDB collision that we created for the smoke over here. And this will be the pyro collision. And this has two fields for the distance VDB, the collision, and the collision vel, which is the vector VDB, and we are only interested in this collision field. So from here I will just drop down a blast, and let's get rid of our collision vel, so we only have this collision distance VDB. And from here I will drop down a null, and let's rename this to pop collision. And let's grab this node and go inside our popnet. And for this we want to use a static object. Let's point the saw path to the pop collision, and let's create a merge and merge this here and reverse the nodes by pressing Shift R. Okay, so maybe I will rename this to fracture collision. And in my collisions tab I want to use a let's set this to use volume collisions, and we want the mode to be volume sample. And also, because this is animated, we have to select use deforming geometry as well. So as I play the simulation now, we should be seeing our collision, and we do. Alright, so this is working, and we can see that this is pretty fast as well, so that's great. The problem here is that our pieces have this hole here, and that means that our points will also fall through the ground. So we also need to import or rather make them collide with this base that is underneath this plane here. So let's maybe go up, and we can go all the way up to our geo init, and this is the base basically that's underneath our fractured pieces. So these are the pieces and this is the base, and we have set up here a collision that we used earlier for our main simulation for the fractured pieces. So we can simply grab this, which is a packed object, and let's just import this in our popnet. So let's go inside here, and let's create a separate collision over here. So just grab these nodes and duplicate these and plug this here and reverse the order, and this can be the base collision. And let's point this to our base geometry that we just grabbed and press enter, and this doesn't have any animation, so we can turn this off, use deforming geometry, and this can be, let's set this to use solver default. And if we go in the bullet data, we need to set this to create convex hull per set of connected primitives, which will be exactly the same way that we set up the same type of collision for our main explosion simulation. So if I press play, we can see here that we have our pieces, and we can show guide geometry, and maybe I can also turn this off for a second, and let's just preview this. Okay, so we can see that this is going to be the collision with the base, and if I press play, let's just check that this is working. And over here, let's also not forget to go to this RBD solver and set the mode back to the default, which is ray intersect. So make sure that this is not using the volume sample method. And we can actually go up, and let's go to our popnet, and inside this object merge we can choose to only import the pop object. So I will use object anything that has pop inside it. So now we only export the simulation to the sub level, and we can play this and see that the particles are these here that are laying on the base. So our base is working. Hopefully we can tell over here. There are some particles that started below our surface geometry, and as a result this will fall completely straight down. And we can create a volume from this base geometry and say that if the particles are inside of that volume, then let's just delete them. So let's go back here where we have our base. From this GeoBase render, I will drop down a VDB from polygons. So turn this into a surface volume, and let's maybe drop this into a reshape and make this just a little bit smaller. So in this reshape, let's set the operation to erode. And I can preview the geometry as well, and we can see that the geometry is just slightly outside of my volume, and maybe we can increase this erode value just a little bit more. So from here I will drop down a null, and this will be base VDB. And I will grab this node now and copy, so Control C, and let's go back to the pop simulation. Let's step inside, and over here I can drop down a pop wrangle, and I will set my input. So the first input, let's set this to a SOP and point to our base VDB. So here I will type float sample, and I will set this to be volume sample. Look for our first geometry, and this should be the first primitive, and look at the current position of the point. And then I can say that if this sample is less than 0, so this will give me a negative value, and it will mean that it is inside of the volume, then I will just want to remove point. So now we should call all of the points that are inside of the volume. So if I press play, let's go up maybe, let's go to our popnet, and all of the particles basically that would be inside of the geometry are now going to be called. And we are still left with the points that fall right on the surface, as we can see over here. And we can see that these particles are kind of sliding a little bit too much, so let's go inside here, and for my pop object, let's go to the physical tab, and let's increase the friction quite a bit, maybe to 0.9. And let's also turn on my fracture collision back on, and let's go up, and let's preview this now. And maybe go to the cache here and increase the cache memory as well. Alright, so this is the result so far, and maybe I can also reduce a little bit the bounce of the particles as well. So let's go back here and to our pop object and reduce the bounce maybe to 0.5. So I want a little bit less bounce. Also, let's go up and let's generate a rest attribute as well, so we can color our particles. And let's resimulate a few frames. And this should be enough. So from here, I want to drop this down into an attribute VOP. Let's set this name to be setCD, and I want to use a noise to give all of these a little bit of a random color and create a more interesting look. And we want to generate this flow noise from the rest attributes. So this will kind of make the noise stick to the particles. So I will drop down a bind and set this to 3 floats and set the name to rest. From here, drop down an AA flow noise. And if I plug this directly into the CD, we can kind of see the result. Let's also drop down a fit range between the noise and the CD, and let's promote some parameters. So let's promote frequency, amplitude, roughness, and from the fit, source min and source max. So if I go up, now we can play around with some of these settings, and I will reduce the source min, maybe increase the frequency, and maybe also increase the roughness a little bit. Okay. And we will use this black and white value as the color inside the render. So we will grade this path inside of Nuke separately, but we only want some difference in the value of the color. So we can use this black and white, the black and white value as a base. And we can see that we are working with 2 million points, and this will all be rendered as spheres at render time with Redshift, and I think this is fine. So maybe if you want more particles, you can go to this point replicate and you can go to the quantity and just increase the points per point. So if I set this to a value of 2, you will have twice as much particles in the simulation. But I think this is fine. And we can see that the collisions are working, and I can show all objects and preview with my geometry as well. Okay. So I believe this should be fine. And from here I can simply cache this out. So let's drop down a file cache. Or maybe we can just duplicate the file cache that we used for the smoke. So let's duplicate this over. Plug this here. And this can be our particles. And I will save to disk.